Hi, welcome to the Introstat lecture series, and we are in the unit of testing hypothesis. And for the previous three lectures, we talk about the basic elements for the testing hypothesis. So we talk about how to define the null hypothesis, how to define the alternative hypothesis, and also what is the p-values, right? So we know the p-value play a very, very important role in decide to, when we try to make a decisions to whether to accept the null hypothesis or reject, we should say accept the null hypothesis. We said a p-value will help us to see whether we will reject the null hypothesis or, fail to reject the null hypothesis here. And we also talk about how about if p-value is not easy to find, then we be able to try to find the critical value. So we also talk about the critical values. And then the lecture number 3, we also talk about a very important concept, because statistics based on samples, right? So any decision you make always associated with an error. So that's why in the lecture number 3, we talk about differences between the type 1 and the type 2 error. And we recognize, unfortunately, these two errors, they don't go hand to hand. If one error become smaller, then the other error become larger. So it's very difficult to try to minimize both errors here. And we also talk about the power of the test is how powerful your test to help you to make the correct decisions. So for these lectures here, we're going to just take a look. One of the most popular tests is, we call this the one population proportion test. We're dealing with this type of the problem all the time. So for example, you want to test what is the high school student graduate rate. Is it more than 70% or below 70%? And also, like, for example, in this city, what the percent of the people, they are the Republican, what the percent of the people, they are Democrat, right? So this type of the problem we constantly dealing with. So in this lecture, we're going to take a look at how do we do the one population proportional z-test, and to get your feeling. So like now, for the previous 3 lectures, we covered the key elements like p-value, critical value, those things. But, one thing we did not cover is the test statistics. Like we talk about, we can test so many different hypotheses. And so for each one, the test statistic will be a little bit different. So for this lecture, we're going to talk about what test we can use if I want to test the population proportion is equal to a certain value or not equal to or greater than certain values here. So how do we do the test here? Okay, so now let's go ahead, go to our lecture notes here. Okay, so what is the, the one proportion, like one population proportion test? So basically our non-hypothesis here, this is how do we define? So we define is the P, that's the proportion, right, or the percent of the certain things you are interested, right? Like a percent of the smoker, percent of the high school graduations, and the percent of the Democrat, the percent of the Republicans, those things, right? So your non-hypothesis, you want to test this percent equal to a very specific value, we say, is the P0. So like you said, it's 30% the populations in the city, is a smoker. So your P0 is 0.3, right? So if you say, in the Texas, we have 65% of the population, they are Republican, then your P0 is 0.65. Correct? So this P0 is the population proportion you are interested in, you want to test. So your hypothesis here, your alternative hypothesis here, remember the alternative hypothesis, what we call it is a researcher hypothesis. So it's the hypothesis, because you don't believe the claim, so you want to test. So if I said a smoker is equal to the 35% of the populations are smoker. So the P0 is 0.35. If you don't believe, so you want to test, is the smoker equal to the 0.35 or not? So we always have three kinds of the alternative hypothesis, right? So the first one here is that P is not equal to P0. That means I disagree, the 35% of the populations, are smokers. But I'm not sure, I don't have data to support it. Is it bigger than 35% or is it less than 35%? So my alternative hypothesis will be what? P is not equal to P0, correct? And this is what we call is a two-side test. Right, because this is a two-side because it's not equal to, so I could test greater than or I could test less than, right? So that's why the next hypothesis here, alternative hypothesis you can test is P greater than P0. What's that mean? That means you tell me 35% of the population are smokers. I really think we have more than 35%. So your alternative hypothesis is P greater than the value you claimed, right? So because of the greater than, so this is, we call this the one side, right? Because you only care, the greater than side, right? So this is, we call this one side test. And because it's greater than, which side we are care about? Right-hand sides, right? So this is one side, right-hand side test, or you can say one side test to the right? Or you say, hey, I really think we kind of educate our population and the people stop smoking. So the percent of the population of smoker is less than what you told me, the 35%. So I believe, so that's what I'm testing is P is less than P0, right? So P is less than the 35%. So this is also, we call this the one-side test. But because it's the less than, so what is the side I'm interested? I'm interested in the left-hand side here. Okay, so we talk about it. So this is the hypothesis we talked about in our previous lecture. So now the test statistic, this is the one we did not cover in our previous three lectures. The reason why is because for different things you try to test, your test statistic will be different. So for right now, I'm interested in the proportion, is the percent is equal to a certain number or not. So the test statistics here for the one proportion Z-test, we call it, this is our test statistic. So we say it's a Z-test, so we use the Z. And you might want to ask why this is the test statistic. Let's use what like a lot of statisticians, they work and they derive the formula, say, hey, this is the best formula to use for test population proportion. So let me write down the test statistic, we call it Z. So I use the capital letter Z to represent that. And so what is the Z? It will be the P hat minus P0. And this is what we call this the standard deviation of the P hat. So what is the SD here? The SD is the square roots of the P0 and the 1 minus the P0 over N here. Okay, so let's take a look at what is this test statistic means, right? So what is the P hat here? The P hat here is X over N here. So let's try to take a look at what is each number means here. Okay, so now let's say here I'm trying to testing 35% of the populations are smoker. right? So I'm testing P is equal to the 0.35. So what is my P0s here? So my P0, this is my P0s, right? So I'm testing, right? So this is the P0s here, all right? So what is the P hat here? P hat, okay, so this is what we call this is our sample statistic. So in order to, to do this test, you have to go to take a sample, right? So for example, you say, okay, I'm going to do this research. So I'm going to take a sample. So what is your sample? You say, okay, I'm going to randomly pick 1,000 people from the city. Then ask them how many of them are smokers. Right? So for these examples here, so my N is what? N is 1,000 here, right? So I'm just randomly pick 1,000. If you randomly pick 10,000 people, so what is your N here? Your N will be 10,000, right? And then what is the X here? So X here is you ask each one of this 1,000 people you pick and say, hey, are you a smoker or not? Right? So they will tell you yes or no, yes or no, yes or no, right? So out of the, out of the 1,000 people, if 298 of the people told you they are the smoker, so the X is 298. So the 298 over the 1,000, that is what we call is the P hat. That is your sample statistic. So you try to test is 35% of the populations are the smoker. Then your data, your statistical data tell you is 0.298, right? So that's why the P hat. So this is kind of like the kind of the statistics we need to be careful, right? So the P hat here, right? So P hat, this is what the test. So this is what is the sample statistic, because when you want to do the test, you want to take the sample. And the way you take the sample, you randomly pick a certain number of the people. So like in this sample, I say I randomly picked, 1,000 people, right? So N is 1,000. Then you ask each one of them, are you smoker? Are you smoker, right? So I find out 298 of them are smoker. And then this is what we call is the standard deviations, right? And then you put the okay, so you put the standard deviation. The formulas here will be, you just put the P0, so it's a 0.65, then 1 minus P0 is 0.65, right? Then N is 1,000. You put the value into this formula, then you plug the formula into here, you can get your Z, all right? Okay, so you get your Z's here. After you get your Z, you can either use the p-values or you will find, if you don't know how to use the p-value, you can find the Z and then compare to the critical values here. So what is the critical values here? Let me give you a table here, right? So this table will tell you here, this is the critical value I'm going to use. And right now, I'm just going to provide you this table, and in the next unit, when we talk about, the normal distribution, we will go a little bit deeper so you will understand where those numbers come from, okay? So for this table, the way to read it is, the significance level. Your test will tell you, I'm going to do at 10%, 5%, and 1%. So remember that in the previous lecture, what is the significant level? That means it's my alpha levels, right? That means that's the type 1 error I'm willing to take. That means that's the risk. When I make a decision, I might have a 10% chance to make a wrong decision, or 5% chance to make a wrong decision. And so in here, this is your HA. So in here, let's tell you here, if, if it's not equal to two sides, then your critical value is 1.64 and negative 1.64, right? And so if you are inside those rejection regions, then you will reject. So this is what okay, let's take a look at so we talk about the two sides here. Let's see how is it, what that means, right? The two sides. So we say here, okay, so this is the two side and this area and this areas, right? So this areas here and this is like alpha over 2 area and this is alpha over 2 areas, right? So this is a two-sided test here, okay? And then in the here, this is what is the critical value. So for example, if this test, for example, let's just say I assume the alpha equal to 10%, right? So alpha equal to 0.1. So let's know what this table tell you. That means this will be 1.64. This is negative 1.64. Then whatever you calculate these z values here, this test statistic, if your z sitting here, so this yellow area is what we call it is rejection areas, right? So whatever, if you calculate the z, if it's 2.13, then you will say, I reject a null hypothesis. That's how do you use this critical value table. So the same time, for the one side here, right? So let's still assume, the alpha is equal to the 10%. So we know how to use the tables here. Okay, so here, let's take a look here. So if it's one side, if the right-hand side, that means in here, okay? So remember the one right-hand side, that means it's greater than, right? So this area, right? So this area is your alpha value, okay? So the same time, this green one, this is your critical value. So this is one side area. So critical value is what? Is 1.28. So the same way, if you calculate the z, if here's your calculated z value, right? Because it's not inside the rejection regions, right? So the yellow area we call the rejection region. It's not inside your rejection region. So we fail to reject a null hypothesis. All right, so the same things here. Let's take a look here. If it's left-hand side, one side also, right? Okay, so if the left-hand side, that means in here. That means it's less than, so your reject region will be here. Am I right? So where is your critical value is here. So now you look at the table, you say, oh, okay, so this is a negative 1.28. Okay, so now you do the same way, you still calculate your z. If your z by chance is sitting in here, then you reject a null hypothesis, right? Like this one here, you fail to reject. That's how do you use, this critical value tables here. Of course, here we assume to the 10%. Then if you're, if you have a different, so like for examples here, if you're different levels here, right? So if you're different levels, then your critical value will be the different, will be, will be different. So it depends on your alpha values here. So these critical values, remember you compare your test statistical value, right? So the Z, this is your test statistic value here. All right. So this is your test statistical values. And then you use your test statistical value to compare with the critical values here. Okay. So now the next thing here, we said, this is a pretty, if you don't have any calculator software, you can always calculate. You don't have like those fancy like a graphing calculator. You can always just use your regular calculator and calculate this value pretty easily, and then compare with the critical value. If you do want to calculate, if you do want to calculate the p-value, you have two ways you can do it. Okay, one is use the TI-84 calculator, and other one is you can use R's here. Okay, so I'm going to show you how to use the TI-84 and how to use R by using these examples, so you can see how easy it is. All right. Okay. So now let's take a look at these examples here. This example, it says here, okay. So this example, it says, a company hopes to improve customer satisfaction. And so the set of goal is no more than 5% negative comments. A Redner survey about 350 customers and find only 10 with a complaint. And does this provide evidence and 95% confidence level that the company has reached its goal? Okay, so first things here, be careful here. So we say 95% confidence. That means I'm 95% sure. So what's that means? Translate to the alpha value. Alpha value is what? Alpha value will be 0.05, right? 5%. That means I only have a 5% chance to make the wrong decision. So that's the same thing like we call it, this is a significance level. And so I'm 95% sure. So that's why my significance level is 5%, right? Because if you're 95% sure, that means I'm only have a 5% chance of making the wrong decision. So the alpha is 0.05. So if you want to use the critical value later, we need to go to this one, right? 0.05, 5%. Okay, let's go ahead. Okay, so let's see here. Okay, so now we said I want to, okay, so I want to find the no, is the improvement, right? So you see whether they improve, so you need to be very careful. So this is what I'm researching, right? So the 5% negative. So that means my research hypothesis really is improved, right? That means the percent of a complaint is what? Has to be less than what? 0.05, correct? And then in here, remember or non-hypothesis is 0.05. Don't get confused with both 0.05. This 0.05 is related to what the problem is here, because I want to have less than 5% the complaints, right? Okay, so that's why you write your alternative hypothesis, P is less than 0.05. Okay, let's take a look at our test statistics here, right? So first, let's try to write it down, what we have here. Okay, so in here, the problem gave me how many people I surveyed? 350. Correct? Okay, good. 350. And how many say have a complaint? 10. So what is 10? It's X, right? X equal to 10. Okay, so now based on that, okay, so we can know, remember the P hat is a sample statistic, it's a percent of the people with a complaint. So it's a what here? Is a 10 over what? 10 over 350 here, correct? All right, so if you say 10 over 350, it will be so it's 0.0257, something like that, right? Okay, so now I'm going to put into my test statistics, right? So my test statistic, this is a given because this is what the people derived, the statistician derived. Okay, so according to the formula, it's what? It's a P hat minus P zeros, right? So P hat. So this is my what? This is my what? P zeros, correct? Okay, so it's a P hat. So P hat is 0.02857 minus P hat. P hat is 0.05, right? Then divided by SD. So So we know the SD, according to a formula, is what? Is a P0s, right? So it's a 0.05 times 1 minus P0, so it's a 0.95. And over how many here? Over 350s, right? Okay, over 350. Now you put this into your calculator, you will get your test statistic. Let me use the color pens here. So you will get your Z is negative 1.8394, okay? So now, if you don't have the fancy calculator, you don't know how to run the R or the software, let's try to use my, the critical value. Okay, this is less than, so this is what type of test? This is one side. Okay, so you do like this, you say, okay, this is a one set test, right? And here, one set, because it's less than, so it's this area. And then you go back to your the table I provide, and you say, oh, it's 0.5% is one side. So which side is less than? So what is my critical value? Less than is here, right? High is negative 1.64. Did you get that? Okay, so now I back here, I say, okay, my critical values here is negative 1.64. And oh, now take a look. What is your Z value? Your Z value is negative 1.83. Where is the Z value? Here, right? Because this is negative 1.8394. So because the Z value, the test statistical value inside the rejection regions, right? So this, this yellow area, we call these rejection regions, right? Okay, so you see your Z-test is inside the rejection region. So what is the conclusions here? You will say, I can reject H0. So I will reject non-hypothesis. Okay, so you write it out. Typical, if you say reject H0 for the people, they do not, they did not have statistical course before, they do not know what, what that means. Okay, so you can say the data provide enough evidence, right? So you can write it out a little better. So you can say data provide enough evidence at a 5% significance level that customer complaints has improved no more than 5%, right? So that means based on this data, I know the customer complaint right now because I reject the non-hypothesis, right? So I will say the, hey, it's improved less than, we have a less than 5% negative comments here, right? Okay, so now the only thing we did not do here because there is the p-values here, right? So like we say, the p-value is not obvious. So we require like some software and or some like a graphing calculator. But you can always use the critical value to make your decisions, right? You can say the 5% is less than, so I can reject. But most of the people, they really like to see p-value. Said, oh, you reject, right? How significant really you reject? Is this test statistics is very powerful, or it's right on the boundaries, right? So now let's take a look. I'm going to show you how to use the TI calculator. It's very, very easy to do, okay? So I'm going to leave the lecture notes and I'm going to go to the calculators here. So let you take a look, how do I do it, all right? So the first things here, you turn the calculator on, okay? Now, the next step here, you go to stat, okay? You push stat. And then you go to test, okay? So remember, you find the test. This is the one proportion Z test, right? So you go one, okay, so it's one proportion Z test. Oh yeah, this one looks like the correct one, right? So you say, what? Okay, so what is your P0? The things you want to test is what? Is 0.05. Is equal to the 5% complaints or not? Okay, so here you see what is your X value. That means you have 10 customers with a complaint. Out of how many? You check the 350s here. Then you go down here, you will have like 3 different alternatives, hypothesis, right? P is not equal to, P is less than, or P is greater than. So for this problem here, right? So I'm going to do is P is less than, right? So my true complaint is less than 0.05 here. So you put your cursor here, and then you push enter. See here now is shining here. That means you know it is, right? And then you go down here, do calculator. Then you do, okay? So now take a look. Okay, so in here, they give you the values, right? So this is how do we read, right? So first things here, they do give you the test statistics. That's pretty neat, right? So it's Z to the negative 1.8394 is the same one we got. And then this one, this is the P hat. P hat, we also be able to calculate from, so it's 10 over 350. So it's 0.02857. That is what we have here. So what is this piece here, right? So this P is, okay, so this piece here, this is the P, the pointer 032926. What is this piece here? This is what we call is the P values. Okay, you get that? So that's how easy to use the TI-84s here, right? Okay, so you use the one proportion what? Z test, right? So basically you just need to input what is your non-hypothesis test, what is your, the sample size, those things, and you will get the same values here. So great. So based on that, we got it, right? So we have our p-value. We just get it from the what? This 0.0329, right? So this p-value is less than my alpha value. So we said the alpha value is a threshold for the p-values, right? So if a p-value is less than that, then we know we reject the hypothesis, right? We reject the non-hypothesis. So of course, we will reach the same conclusion. That is how do you use the TI calculator to help you to get the p-value. So you see it's a pretty easy things. So let's try to make a note here. So when you try to use the TI calculator, and so what the function you need to use here, so you need to go to what? Stat, right? Okay, so you need to go to stat, okay? So you go to stat, you push these keys here. Now after the stat, now which function you go down, right? So after stat, you go to the test, right? Then after test, which one you choose here? You choose one proportion Z test, right? Then you got all the information. They give you the test statistics, they give you the p-value, they give you the p-hat, and so you can make the decision. Also, they give you the choice to see if you want to do the one-side test or two-sided test here. Okay, so that is how do you use the TI-84 calculator. It's pretty handy, right? Okay, now let's take a look. How do you use the R? Okay, so let me stop here. Let me go to the R. Okay. Okay, so here, this is the R screens here, right? Okay, so now, okay, so here is the code you can use. Okay, so here I will say result. So you can, this one here, that means I just give a name result as the analyze result. Later, you know, you will, let's just name. You can give any name. You say John, Mary, that means your result are going to be in here. So you do like this, you put like that, and then you do a proportion, PR, you do a PROP and the dot test, right? Okay, so then it's very similar, like the, like the one in the calculator, you say X equal to 10 and N equal to 350 and P, remember this is your P0s, right? So P0 is a 0.05 here, right? And then in here, you say correct equal false. And for the correct, this statement here, correct equal to false, is always put that. This is just telling the system, I don't want to do continuity correction. You probably don't understand why, but just remember you put a correct equal to false, right? Then you can put a alternative. Okay, alternative is equal to, because that means it will tell you which side, so you will say is less, right? So if right-hand side, right? So here, look here, the R is very good. They give you this hint. They say you can type the two-sided or less or greater, all right? And then it will give you the, so that's it. And then you hit enter, right? So it's calculated. You want to see your results, whatever the name you put in here, you type in SULT, right? You type in, that's the name. If you type John, then you type John's, right? If you use John, if you use Mary, you use Mary. And then now here, it's pretty cool, right? So you say this is like, give you the title, let's say one sample proportion test, okay, without a continuity correction. That's what is this correct false means here, right? So let's say 10 out of 350. Okay, so see here, this number here, p-value is 0.03293. And that is exactly what we calculated from the calculator. Okay, so now this one's here, this is your p-hat. That's what we call this a simple estimate, is p-hat. That's the 10 out of 350. So it's 0.0285743. And then you probably ask, you said, hey, where is my test statistics? The R in here, they give you a little bit different. So the test statistic they use here, this is 3.3835. They call this is X square, okay, square test. So in order to do the Z test, if you want to calculate the test statistics, right? So the way you can calculate that, it will be, so your Z test will just be, you take the square roots of the 3.3835, and because this is left-hand side test, right? Because it's less than, right? So in here, took here, true, P is less than, right? So that's why you put a negative sign in front of it, okay? So when you take the negative sign in front of it, and then what do you will have here? Your z-test statistics will be negative 1.8394. So you will get exactly the same values here, right? So this estimate samples here, right? So this is what we call it is a p-hat. So this number here is will give you is 10 out of 350s. Okay, so it's pretty cool, right? So the R, it will give you the same answers here, right? Okay, so that is how to use R's here. Let's go back to my lecture notes here. So let's try to write it down. How do I get the, how do I use the R to do the testings here? So let's see here. Okay, so let's try to put in here. Okay, so this is the, so this is the code, right? So let me color that with maybe what, red, right? Okay, so this is the code, right? So you can use, okay, so this is a code you can use for the R's here. Like I said, result, this is just a name. You can give any number you want. You can get any name you want. You say John's, Tom's, Mary's, right? Then here is a proportion test. You put the input the XN, and this is to be careful, right? So in here, this is the one. What is, you know, what is this one here? This is your P0s, right? So don't get confused with like in alpha. Then correct is false. We say this one you always put like this. So because we have not talked about the continuity correction yet, then alternative is less, right? So you can have a different alternative, two-sided and or greater, right? Okay, so that's it. That is this lecture, how to testing the hypothesis, and is one the most popular test you will see almost like in the real life. You will deal with it almost in a day-to-day basis, right? So it's to test one population proportion test. Okay, if you want to test, say, the percent equal to a certain number, the things like a cancer survival rate is 65%, right? So it's everywhere, right? So this is, we call this a proportion test here. And we just introduced the same concept, right? So like I said, that's why for each different test, we are associated with a different test statistics. Okay, so that's why, you know, like later you will probably need to do a table. So this is a test statistics for the one proportions, right? And then we have the two proportion z-test. So it's like, say, hey, if I want to compare the, you know, two high schools, their graduation rates are the same or not. Now you have two populations, two proportions you want to compare. Then what is the test statistics, right? So the only thing will change is the test statistic, and all the other the process will be the same. You still do define the hypothesis, you do the test statistics, you find the critical values, or you use the p-values here, then make conclusions, right? All right, that's it. It's fun, right? It's a lot of fun when we're doing those hypothesis testings here. Okay, and looking forward to you to talk about the next units here. Okay, you guys have a good day. Okay, bye.